For your Cornell notes, I just drew a couple lines here. And here's the title. You can write down the title on your paper, 11.1, Modeling Equivalent Expressions. Put your date. I'm not getting a lot of questions from anybody. So you guys, you need to be coming up with questions. You don't understand everything I tell you. So make sure that you're writing down the things that you don't understand. I'm going to go kind of quickly through this. You do not need to take notes. I repeat, you do not need to take notes on this first activity. Just listen and watch. Okay, this is a balance right here. And a balance, when it's balanced, one side will be the same weight or the same value as the other side. It won't be tipped any. It'll be, I don't know what else to describe it. It'll be balanced. And what you do to one side of the scale, you need to do it to the other side too to keep it balanced. Kind of like a numerator and a denominator. What you do to the numerator, you have to do it to the denominator to keep it balanced. So A says, write an expression to represent the circles on the left side of the balance. So we have 2 circles and on one row and 3 on another. So that's going to be 2 plus 3. And then the value of that expression on the left side, the value of it's 5, because when you add it together it's 5. Remember, an expression is a math problem that doesn't have an equal sign. C says write an expression that represents circles on the right side of the balance over here. So we have 1 circle on top and 4 below it, so that's 1 plus 4. It also equals 5. E, since the expressions have the same value, the expressions are equivalent. So they're saying that 1 plus 4 is equal to 2 plus 3, because they both equal 5. F says what will happen if you remove a circle from the right side of the balance. Okay, if you remove a circle from over there, the left side will be heavier. If you add a circle to the left side of the balance, what can you do to the right side to keep the scale in balance? So if we put another circle there, we would have to do what? We would have to put another one here to keep it balanced. Add a circle to the right side. So in our reflection it says, what if? Suppose there were 2 plus 5 circles on the right side of the balance and 3 on the left side of the balance. What can you do to balance the scale? Okay, what would we need to do to keep it balanced? What's the value over here? 1, 2, 3, 4, 5, 6, 7, or 2 plus 5 is 7. Okay, I would need how many more circles to make 7 on this side? 3 plus what equals 7? 3 plus 4. Okay, so I would have to add 4 to the left. So that's how you would balance the scale. I know that disappeared really quick. Explain how the scale models equivalent expressions. You can see that it is equivalent because there are 7 circles on each side. Alright, so we're just talking through some of this. There's not really any work to do, but I do want you listening carefully. I'm going to make sure that your volume is up on your iPad. And like the page before, I don't want you taking notes on this. Just listen. An algebraic expression is an expression that contains 1 or more variables and may also contain operation symbols such as add or subtract. Variables are the letters that you see in math. Letters in math. Sometimes they're in a formula, sometimes they're just in like an expression. A variable, oh here you go, it defines it right here, is a letter or symbol used to represent an unknown or unspecified number. That means that we do not know. We don't know. Remember, you're not writing this down, okay? We're just talking. Okay, and then a constant is going to be a specific number whose value doesn't change. So you're looking at this algebraic expression right here. These are expressions. Remember, they're little math problems that don't have equal signs. The number is the constant and the variable is y. Okay? Here we have two variables. We don't know what either one of those numbers is, and then here is a variable, and there's no constant with it. So these are algebraic expressions. Okay, here's some examples of expressions, but they're not algebraic. There's no variables in them. It's just a bunch of constants. 15, 12 minus 7, 9 divided by 16. Those are just expressions. There's no algebra involved with them. So when we have algebra, that means that it's going to have variables in it. Okay, in algebraic expressions, multiplication and division are usually written without the symbols. Okay, so instead of like 3 times n, oh my goodness, that looks like a letter, doesn't it? And in algebra, it's hard to tell if it's a time sign or a letter, so we just pretty much don't use the time sign anymore. So if we want 3 times n, we can put that letter and that number right next to each other with no space in between. And then I've been showing you the multiplication dot. Here's one right here. Okay, 3 times n, or that's the same thing as n times 3 if you flip it. Okay, here, 3 divided by n is going to be written like this. And you guys know that. We've been talking about that. That's like TIBO, top in, bottom out. We have been discussing how that is division. This is some elementary terms. Okay, this is all terms that usually means addition. Okay, not always. Keywords for addition: added to, plus, sum, more than. Subtraction: subtracted from, minus, difference, less than, take away, taken from. A lot of the times you'll see how much greater, how much older, heavier. Okay, I misspelled older. I'm thinking of older because I'm so much older than you guys. Multiplication: times, multiplied by, product, groups of, or just of. And then division: divided by, divided into, quotient, equal, groups, sharing. There's so many they left out. So this table is pretty much not that great. Okay, now I want you to take notes. So when I'm looking at your Cornell notes, these are some things I'm going to be looking for. It says write each phrase as an algebraic expression. So A says the sum of 7 and x is going to be 7 plus x. You had to know that sum means to add, and then 7 and x. 7 plus x. Pretty easy. Okay. The quotient of z and 3. So z divided by 3. Here they wrote it in the TIBO way. Z divided by 3. I would accept either one. Okay. So you should have written down the sum of 7 and x, and then that right there. You should have written down the quotient of z and 3, and this right here, or this one. Okay, now let's look at B. B says, write a phrase for each expression. And when you have 11 right next door to the variable x, there's no space in between, that means multiply. So we could say, you don't need to write this down. Don't write it down. These problems you need to write down n times 7. I want you to write it like this, 7n. That means n times 7 or 7 times n. Does that even look like an n? Let's try it again. 7n. Okay? 4 minus y, 4 minus y. 13 added to x. That means you started with x and we added 13. So when I look at your Cornell notes, I should see this written down and this. If you want to put an equal sign there, you can. 4 minus y, I want to see these things. Okay, write all that down. Write a phrase for each expression. So now we're going backwards the other way. X over 12, we would, and then 10y means 10 times y. You know what? I am going to erase that, and let's write this. This is what I want to see. The product of, because product is the answer to multiplication, the product of 10 and y. Okay, now we're going to model it. Okay, 7 plus x. So we have 7 parts, and then we're adding unknown parts here. Okay, that's 7 plus x. You don't need to write this down. Don't write this down. We're just looking at this. Z divided by 3. So we have all of this. They're saying that's Z. We don't know how much it is, but it's been divided into 3 parts. Okay, so in your notes, you're going to write t minus 2. Okay, draw one rectangle like this, and then you're going to label the whole thing as t, and then you're going to take out 2 parts. We don't know how big those parts need to be, but it doesn't matter. You can see that there's been 2 parts taken away. Okay. On 8, write down 4y, and then you're just going to have 4 groups of y, like that. Okay, on this next part, do not take notes. We're just going to look at these drawings. Gatriana and Andrew started the day with the same amount of money. She spent $5 on lunch, and he spent $3 on lunch, and then later he spent $2 on an after-school snack. So we're going to model what that looks like. The whole rectangle is how much they started with, the $5, or no, it can be $5. We don't know. That's why we put an X there, because we don't know what it is. And then she spent this much on lunch, and this is what she has left over. Okay? So the expression for that is whatever they started with minus the $5 for lunch. That represents what they have left over. And then Andrew started out with the same amount. We don't know what it is, but we have to use an X2 because it has to be equal to what she did, what she had. And he spent $3 and then 2. So what is left over is this expression right here. What they started with minus lunch minus snack. Okay, how much did he spend? He ended up spending 5 also, so these are equal. All right. Okay, let's go to the next page. Oh, there's not another page. Okay, so you guys can go ahead and get started on your next activity.